Alright, so we're going to take a look at mean value theorem versus Rolle's theorem together. So again, just to remind you as to what mean value theorem and Rolle's theorem are, Rolle's theorem is just a special case of the mean value theorem. Okay, so what are the things that needed for mean value theorem? One, it has to be continuous on a closed interval. What does that mean? That means there are no denominators or roots. Remember, for it to be discontinuous, the denominator will be 0. Alright, number 2, differentiable on the open interval. What does that mean? That means once you take the derivative, there are no denominators or roots on the derivative. Alright, so that takes your means value theorem. It is an open interval on the differentiation because you can't take the limit from both sides of an endpoint. Okay, so if you had an endpoint, the limit as it comes from the left doesn't exist, only the limit from the right. That's why it's an open interval. Okay, that's why the derivative is always an open interval. So you need to remember that. This is a listening check. Color in continuous on closed interval. Right, so let's take a look at the mean value theorem first, because that's like the mother to the Rolle's value theorem. So what does the mean value theorem say? The slope of the tangent line is equal to the slope of the secant line. Notice I'm keep doing these videos because this one is very important. You have to remember the 3 things. Slope of the secant is equal to the slope of the tangent, or they're parallel to one another. So the slope of the tangent is, remember, is a derivative. The slope of the secant is change in y over change in x, which would mean f of b minus f of a over b minus a. That's the slope of the secant. Alright, the Rolle's theorem is a special case of the mean value theorem. I'm going to show you exactly what I mean by that. This is a listening check. Color in number 2, differentiable on an open interval on the top. So let's say you had this curve, okay, between the 2 endpoints A and B, or the interval A and B. The slope of the secant line is the slope between the 2 endpoints, right? Which is, in this case, horizontal. So the slope of the secant is 0 because it's horizontal. The mean value theorem says that there's at least one place where the slope of the tangent is going to be equal to the slope of the secant. So the slope of the tangent has to also be equal to 0. At least one. In this example that I have drawn, there are 2 of them, but there has to be at least one. Okay, so what that means is in order for this to happen, f of a must be equal to f of b, because that's the only way that the slope is going to be equal to 0. Therefore saying that the derivative of slope of tangent is also equal to 0. So remember, the Rolle's is a special case of the mean value theorem. So let's take a look at an example. We're going to do both of them. Alright, so remember, it has to be continuous, which means the denominator cannot be 0. In this case, it cannot be 0, and 0 is in our interval, so I can't ignore it. So I don't even have to continue on. This is not continuous at x equals 0, so therefore the mean value theorem, or Rolle's theorem, does not apply to this function. So we don't have to waste our time finding it. But if you did do it without checking continuity or differentiable, you'd see that there'd be no c anything. Alright, so let's take a look at another example. So again, is this continuous? Yes, it's a polynomial, so it's continuous. Is it differentiable? Well, let's take the derivative and look. Alright, so this one's relatively easy to check. So take the derivative, you're going to get 2x minus 5. Alright, so is that continuous? Yes, it is. So the derivative is also continuous. Alright, so the mean value theorem says that the slope of the tangent is equal to the slope of the secant. This is a listening check on example 3. Color in not continuous at x equals 0. Not continuous at x equals 0. So the derivative of that function at that point is 2x minus 5. And that has to equal to this, the slope of the secant. So let's find f of b. F of b is, you're just plugging in 4. So you're going to get 16 minus 20 plus 4. Minus, and then you're plugging in 1, so you're going to get 1 minus 5 plus 4 all over 4 minus 1, because b minus a. So that's going to give you 2x minus 5 equals 0. So 2x has to be equal to 5, which means x is 5 over 2. Now remember, it has to be the interval between the interval 1 and 4, and is it? Yes, it is. So that's my c. So my solution is 5 over 2. So Rolle's theorem is a special case of the mean value theorem, which says in addition to it being continuous and differentiable, when you evaluate the 2 endpoints, the y values must be the same. So let's check that. So the third step for Rolle's says that f of a must equal to f of b, which 0 is equal to 0, which is true. So in that case, it says that the derivative At that point, c has to equal to 0. So what's the derivative of our function? It's 2x minus 5, and that must equal 0. Solve for x, you're going to get the exact same thing, 5/2. Is that in the interval? Yes, it is. As you can see, ROLLES and MVT are the same thing, only the ROLLES theorem is a special case of the MVT, which basically says that the y values must be equal. It's not always equal. That's why you have mean value theorem, but sometimes it is, which is why you also have the ROLLES theorem. So let's practice.